Hi dear students, welcome to Math Universe with Dr. Naseer Ahmed. Today we are going to start with the chapter Vector Algebra. Let us mention the chapter name. Chapter Vector Algebra. Yes, we are dealing still with PUC and we can expect 7+ marks from this chapter. Now, as usual, let us try to understand the concept. Let us try to understand in detail from very basic. Now, first thing is, what is a scalar? Scalar is defined as any physical quantity having only magnitude. When I say magnitude, we mean to say length. It should have only length. Any physical quantity which has got magnitude, nothing but length. For example, time, mass, distance, okay, etc. Whereas, what is a vector? It is defined as any physical quantity having both magnitude. When I say magnitude, we mean to say length as well as direction. Example can be velocity, displacement, acceleration, force, etc. Now, dear students, let us move on regarding representation of a vector. How are we going to represent representation of a vector? How are we going to represent a vector? See, let us consider a line. As soon as I consider a line, don't forget line is of infinite length. So now here this line, as you can see, can go, means it can be directed from, let us suppose I've got one arrow mark here. It can go in this direction, or the same line can go in the reverse direction. The direction can be any of the two. Now, when we are going to confine the line with one particular direction, then we say it is a vector. So let us suppose that I've got a point A here, then I've got a point B here, and I am directing the line from A to B. Now this AB is a line segment. What is line segment? Part of a line, a finite length. Don't forget, line has got infinite length. So this particular length which we are talking about, AB, I have given an arrow mark, which we say that we are going to direct from A to B. So this we can also write in small letter a. So we are representing vector as just vector A or vector AB. Now in this vector AB, the starting point is A. This we call initial point. Whereas B is the terminal point, the end, okay, till where the vector is specified. This is terminal point. Now coming to magnitude. How are you going to write the magnitude? See carefully. Coming to magnitude, how are you going to represent this? See, magnitude actually stands for the distance between the initial point and the terminal point. Nothing but this distance. So that we can write as AB vector. See, this arrow mark indicates the vector. And for example, here, no, as soon we see arrow mark from A to B, okay, A is what? Initial point, and B is what? Terminal point. Now for magnitude, we are going to give a modulus sign which represents that we want a length. Let's suppose you don't want an arrow mark, then you can write just AB. This also represents what? A length. It's very important to understand the representation. Many students in hurry, they won't write arrow mark for the vector. Whenever you're not writing arrow mark, you're writing what? Actually a scalar quantity, a magnitude. The other way of writing this can be just a odd modulus of small vector A. So these are the notation. Okay, how we are going to represent a vector I have spoken here. Kindly make a note. Yeah, obviously these are line. Okay. Kindly make a note. Now let us talk about position vector. Let us understand what is this position vector. Yeah. Position vector. Any vector whose initial point is origin. Now just now we spoke about initial point and terminal point. Initial point and terminal point can be anything. Any point it can be. But to be specific, whenever we talk about coordinate system, as we are dealing with 3 dimension, so this is, say, yeah, it is perpendicular, fine, z axis, y axis, x axis, origin. And if I talk about a vector, let's suppose the point is here. Now if I join this, better, yeah, I will join this side, okay, because this is very clear that this is not the extending x-axis, okay, because if I take here, now it is looking like negative part of x-axis. I'm just talking about a point here, and if I join from the origin, I have got a vector OP, and this we call position vector. Any vector whose initial point is origin, that vector is known as position vector. Let us suppose the point P has got coordinate x comma y comma z. So now this OP, if at all I want to find the magnitude by using the distance formula, since the origin coordinates are 0 comma 0 comma 0, we can use distance formula. We'll get square root of x2 minus x1 the whole square. Nothing but x minus 0 will be x square, plus y minus 0 will be y square, plus z minus 0 will be z square. So this will be the magnitude of the given vector. Magnitude, sorry. And here the vector will be vector OP is equal to, so vector OP is equal to xi cap plus yj cap plus zk cap. So we should be always ready to go from coordinate to vector form and vector form to coordinate. See very carefully. The point P coordinates are x comma y comma z. X will come from the x-axis, y will come from the y-axis by coordinate, I mean to say, and z coordinate will come from z-axis there. So along x-axis, y and z, you can see I, j, k, these are the unit vectors. So dear students, we are going to represent this by a small letter r. That's for your vector. Now here vector OP I can also write as vector r here. Okay. Similarly here we can write as modulus of vector r. So these two are same. Now in practice what we do is, whenever we talk about any vector, so by here z and x-axis, from the origin, whenever I join any point, for example, let's say point A is there here, point B is there here, point C is there here, I can join them. Point A I joined, point B I have joined, and point C. After joining, as soon as I give an arrow mark, all are what? Position vector. So in place of writing vector OA, we just write small vector A for this. So in place of vector OB, we just write small vector B. And for vector OC, we just write small letter vector C. Okay. So we can also say that now one question can come, how many position vector do we have? We have infinitely many, because coming to our 3D space, each point can be joined with respect to origin, and we will have infinitely many what? Position vectors. Infinitely many position vectors. Now let us try to understand direction cosines. What is this direction cosines? See, for this, again I am considering the coordinate axis. So here y, z and x-axis from the origin. See carefully. From the origin, again if I take a point P here, and if I just join this vector OP is making some angle with the coordinate axis XYZ. Along x-axis there is an angle alpha. Along the angle between OP vector, that is R, and x-axis what? Alpha. The angle between the vector OP with y-axis is beta. The angle between the z-axis and the vector OP is gamma. This alpha, beta and gamma are called direction angles. So direction angles, when we say, it is an angle made by the position vector with the coordinate axis. On this, if we take cosine, that is cos alpha, cosine values, okay, for all the three, cos alpha, cos beta and cos gamma are called direction cosines. What they are called? Direction cosines. So whenever we take cosine and cosine on the direction angles, we call direction cosines. Now one question will surely come, why it is only cosine taken, why not something else? Correct? So for that, just see carefully. If I drop a perpendicular on y-axis, don't forget the length here will be y, because along y-axis, y, if I take the point to be x comma y comma z, along x-axis the length is x, along y-axis the length is y, along z-axis it is z. Now see, coming to cos beta, which are the two information we have got in this triangle OPA? Here we have got information only about this side and this side. We don't have much information about this, which we can take. But coming to this, which trigonometric function can take the information about this vector R and this? Be careful. Let us just give a mod here, because now I want with respect to length, which is a trigonometric function which can take count of this length and this length. Since beta is here, and for beta y is adjacent, and since this is 90 degree, this OP will be what? Hypotenuse. So which is the trigonometric function which can take account? It is cosine only or secant. So cos adjacent, that is y, hypotenuse is modulus of r. Because of this itself, we take what? Cosine there. Okay, I just thought I'll give a reason. Now we also have got a relationship similarly, before I comment about the relationship, see, for cos beta, y by mod r. So similarly, what will be cos alpha? That is angle made with the x-axis. So I'll get x divided by modulus of r. Then what about cos alpha beta gamma? That will be z divided by modulus of r. Okay. Now we have a relationship between direction cosine, and that relationship, let I try to make you understand how we get that. So this is our note number 1, this is our note number 2, and now this will take as note number 3. Now you see note number 4. Cos square alpha. What will be cos square alpha plus cos square beta plus cos square gamma? Let us try to understand. Cos alpha, as you can see, it is x divided by modulus of r. Okay, since I have a square, I give a square for both. Then plus, see, as I discussed in the previous concept, that whenever modulus is there, I can write without arrow, then also it is what? Magnitude. So from here, just see carefully, cos beta is y divided by, just select r square. These both are what represents magnitude of r with a square. Okay. Then cos gamma is z square divided by r square. LCM is r square. So since LCM is r square, so r square by r square is 1 into x square is x square plus y square plus z square. But what is this? See here itself. Or you can come back here. What was vector r modulus? This. If I take square on both the sides, modulus of r square will be, square bit bigger, x square plus y square plus z square. So x square plus y square plus z square is what? R square with the mod. So I can just substitute numerator to be what? R square divided by r square. Both will get cancelled, will get 1. Therefore, we will get cos square alpha plus cos square. Okay, I need some space. So let bit behind. Nothing wrong. I don't think we can accommodate in a small space. So see carefully. Now we can just comment from here that cos square alpha plus cos square beta plus cos square gamma is equal to 1. We also denote, we got 1, no? 1 is equal to this reference I wrote. We also denote cos alpha by L, cos beta by M, cos gamma by N, standard notation. So we can write that this is, or yes, this will be L square plus M square plus N square is equal to 1. This is the relationship between direction cosines. Okay, that whenever you take the sum of the square, it's always equal to 1. It will be a very handy and important result. Okay, kindly make a note. Okay, dear students, having understood about the relationship about direction cosines, let I give a heading here. What we did here, relationship between direction cosines. So in short, let us DCS. Fine. So the relationship is the sum of the square of cosines will be equal to 1. Now here, I hope it's understood from your point of view that this length, as I said, no, x, the length on positive direction of x-axis is small x, and on the positive part of z-axis will be small z. And with the symmetry, we just obtain the remaining, right? Now, having understood this, see carefully. Let us try to talk about this again here. We have got, consider second order. First we have what cos alpha we take, that is x by mod r. Then cos beta we have, that is y by modulus of r. And then followed by lastly we have got cos gamma, that is z by modulus of r. The coordinate we have taken as x comma y comma z. Let us try to solve for x, y, z. Just see from here. X will be equal to, cross multiply here, we will get mod r into cos alpha. Then y will be, again cross multiply is mod r is equal to cos beta. And lastly, z is equal to mod r into cos gamma. These are our direction ratios, which we denoted by small letter a, b, c. These are called direction ratios. Now, what are direction ratios? Any number which is proportional to direction cosines. Now, see carefully. Since we are going to take this a, this is b, this is c. Okay, when you can take out x comma y comma z, but a, b, c is a direction ratio, and that is taken as this. Now if you think of dividing, I said the what is direction ratio? Any number which is proportional to direction cosine. Now see carefully. For A it is, just see this, for A it is modulus of R into cos alpha. For B it is modulus of R into cos beta. We are just going for some primary things, elementary things. Listen carefully. Now if I take the ratio between direction cosines and direction ratio, see carefully, direction cosine by direction ratio. Okay, direction cosines, as you know, it is cos alpha, right? Now if I talk about x component, so here we have got direction ratio to be mod R divided by cos alpha, correct? These are our ratios. Now come to this, means y coordinate. So it is here cos beta. Cos beta is taken ratio with this, correct? Lastly, cos gamma ratio is taken here. Now see carefully here. In each of this, cos alpha get cancelled, cos beta get cancelled, cos gamma get cancelled, and it is all equal to 1 divided by mod R, 1 divided by mod R, 1 divided by mod R. That's what we are saying, that how to know a given number is direction ratio or not. If I take the ratio between direction cosine and direction ratio, it should be proportional. And since I have taken ratio of direction cosine to direction ratio, it will be reciprocal of the magnitude. Other way around, if I take direction, means the ratio between direction ratios and direction cosine, then the ratio will be length of the vector in place of reciprocal of the length of the vector. I hope this point is clear. And from here, one more point, it's very clear. How are we going to address and how we are going to know which is direction ratio and which is direction cosine? Very simple. For coming to direction cosine, note, as soon as I say direction cosine, this relation holds good. Nothing but cos square alpha plus cos square beta plus cos square gamma is equal to what? 1. Whereas for direction ratio, this is for direction cosine. For direction ratio, DRS I'll just say, okay, but there is no short form method, just for our class. Now since our direction ratios are ABC, if you take the sum of the square, this will never be equal to 1. This is how you are going to categorize whether a given set of numbers is direction ratio or direction cosine. For direction cosine, sum of the square should be equal to 1. For direction ratio, it will not be equal to 1. Okay, but direction ratio is proportional to direction cosine. If I take direction ratio divided by direction cosine ratio, then it will be length of the vector. But if I take direction cosine by direction ratio, it will be reciprocal of length of the vector, nothing else. Okay, kindly make a note. Dear students, now let us discuss types of vectors. So coming to types of vectors, in this the first one is zero vector. What is zero vector? Any vector whose magnitude is 0. Now see, when we discuss the representation of vector, I just gave a line and I gave a direction from A to B. So the length of this vector is AB and it is directed from A to B because of the arrow mark. Now the length of this is AB, but as soon as I say zero vector, the length should be what? 0 for zero vector. So this length should not be there. So see carefully, before I just go and again I repeat. So for this vector, the vector is AB, where the initial point is A and terminal point is B. Now as soon as I say zero vector, this length should be 0. So just see, I am erasing it. I am making the length to be 0. Now the length is 0. Now this is the point here. Now what is the initial point and terminal point? Both are here. So the 0 vector here will be A. So what I mean to say, whenever it's not a 0 vector, you can see initial point and terminal points are different. Whenever initial point and terminal point, I repeat, initial point and terminal points are same, then it is what? 0 vector. And we write O with a narrow mark. So always 0 vector is denoted by O with a narrow mark. Similarly, let us suppose that whenever we have got BB, it is also what? 0 vector. Whenever first letter and second letter are same, nothing but initial point and terminal points are same, then we say it is 0 vector. Now there is no a particular definite direction for 0 vector, or we can say that there is no, since there is no magnitude, so there is no definite direction, or we can say it can have any direction. Okay. Next comes unit vector. What is unit vector? Any vector whose magnitude is 1. If I take the magnitude of the given vector and if that length is 1, then we say it's unit vector. Okay. Next, and usually for unit vector we denote by A, then we give a cap as soon we say it is unit vector. Okay. So but if I take magnitude, it should be equal to 1. Next is co-initial vector. What is co-initial vectors? Two or more vectors. I have used the word plural here. Okay, so it is more than one vector. Two or more vectors are said to be co-initial vectors if they have got same initial point. I would like to give a diagram. In NCERT they have not given a diagram, but I feel if we give the diagram, things are very clear. And we just see this. I'll take this as some A, then here B, then C and D. For all the vectors, that is AB, AC and AD, what's the initial point? A. So whenever the initial points are same, then we say it is a co-initial vectors. We can also denote just by a small letter. This is vector A, this is vector B, and this is vector C. Write this. Okay. And here I have not mentioned what is the formula to find unit vector. In short, we will discuss that as well. But anyway, for you to have clarity, here we will discuss. It is vector A divided by its own magnitude. Okay. Here I just said a definition that any vector whose magnitude is 1. As soon we know that the given vector is a unit vector, then we will say A cap. Okay. Fine. So please don't get confused with this. Next comes collinear vectors. Before collinear, we'll take equal vectors. Okay, equal vectors. Two or more vectors are said to be equal vector if they have same direction and same magnitude. What's the meaning of that? See these two vectors are given the same direction, and even if you see, the length is also same. So the direction is A to B, and here it is C to D. And whenever the two vectors magnitude is same, direction is same, we write this one. Vector AB is equal to vector CD. Okay. Next comes collinear vectors. Two or more vectors are said to be collinear vectors if they are parallel to a given line. This is the line given here. Okay. So let us suppose I've got one vector which is parallel to this. So AB. One more vector will take. See this carefully. CD. One more vector will say. See this. Let us say LM. So LM, AB and CD all are parallel to a given line L. Okay, for line we'll have two direction. Okay, so more on this when I take 3-dimensional geometry, then I'll discuss about the line. But presently, coming to vector AB, vector CD and vector LM all are parallel to the line L. This we call collinear vectors. And just see, for this AB, I'll draw one more which will be in opposite direction. It can also happen that it is okay. Let us name this LMNP. One more I can have here. Let's suppose ST. ST and AB both are actually equal vector. So coming to equal vector, the direction and magnitude should be same. But coming to collinear, just see, it should be only part parallel. So collinear vector and equal vector. Equal vector is also at the collinear, you can see. But every collinear vectors need not be equal vectors. I repeat, every equal vectors are collinear, but every collinear vectors are not equal vectors. Okay. Now all these are collinear. Next, negative of a given vector. Negative of a given vector. Just see the word negative of a given vector. Already I have got one vector A to B. The direction of the vector is from A to B it is. Now let us suppose that from this initial point A, I am going to go in opposite direction and I am going to give the same length as we have got AB. Let us suppose I will give us AB dash to have a clarity. So if you see AB and AB dash, both length are same but directions are opposite. This we call negative of a given vector. And how we are going to write this? AB is equal to what? AB dash. But here you see carefully, the length is same, fine, but the directions are opposite. So I will give a negative sign here. This negative implies that the direction of both the vectors are opposite, but length is same. Okay. I hope this point is clear. So this is all the type we have got. Here just I want to quote one vector which we are discussing throughout our syllabus, free vector. What is this free vector? Any vector which can have a parallel displacement such a way that direction and magnitude is not changed. See, if I talk about one vector like this direction, see, this vector is moving from, let us suppose L to M, okay now? So direction is towards M. So if I take this as a vector, see this parallel displacement, I say, see, I am not changing the direction, just I am moving parallel to this vector. You can see I am moving parallel to this vector without changing the direction and without changing the magnitude. This we call what? Free vectors. What are free vector? It is a vector. Again, see this, I've got one vector here. So what are free vectors? It is a vector which can move parallelly without changing the direction nor the magnitude. This we call free vectors. Throughout our syllabus, we are going to deal with free vectors. So I can have that vector here, that it is moving parallel without changing the direction nor the magnitude. Okay. Localized vector means we cannot do so. It means we cannot move parallelly. Okay. But in our syllabus, we are dealing with free vectors where we can move parallelly without changing the direction nor the magnitude. Kindly make a note of this. Now let us move on to next concept, that is addition of vectors. See, let us take two vectors. One vector is vector AB. Other vector, suppose it is here and it is DC. So as I discussed that we are discussing with respect to free vectors throughout our syllabus. What are free vectors? Whenever we are going to have a parallel displacement without changing the direction and magnitude, that we refer as free vectors. Now here you see vector AB and vector DC is there, where B is the terminal point for the vector AB and D is the initial point for vector DC, and this I will take a small vector, okay, B. Now we are going to position this vector such a way that, see this carefully, there is a vector AB here And now I am going to go for a parallel displacement and I am going to position here. At B, I am going to position the vector BC. When I am going to position here, okay, and this is C. Now B and D has coincide. So now you see carefully this part. What is happening here? The two vectors are positioned such a way that terminal point of the first vector and initial point of the second vector coincides. Then this is vector B. I repeat, the terminal point of the first vector A and initial point of the second vector B both coincide. Then the resultant, nothing but the addition, is given by the third side of the triangle, that is AC. This will give you the sum of both the vector. So trying from here we can see that vector AB plus vector BC is equal to what? Vector AC. This is called triangle law. Again I repeat, the two vectors are positioned such a way that the terminal point of the first vector and initial point of the second vector both coincides. Then the third side is given the resultant. Nothing but resultant, when I say this, addition. Okay. Now vector AB plus vector BC is equal to vector AC. Now some inputs we can get from here. If I just transpose this, then we are going to have vector AB plus vector BC minus vector AC is equal to 0 vector. And minus A vector minus vector AC is same as, see carefully, it's a negative vector for vector CA. We discussed this in types of vector. When I say minus AC vector, this is also same as vector CA. It is this CA coming in the negative direction. Now here what we have understood, see carefully this part. It is AB, that is here, then BC, that is here, then CA, I think this side. If I just go in cyclic order, AB, BC, then CA, I get what? 0 vector. Again, see carefully. A to B, here, then B to C, correct? Then C to A. We started from A, we went to B, then B to C, then C to A. Again, we came back the same. Initial point and terminal point will coincide. Okay, we get a 0 vector. Here it is a vector symbol. Next, let us try to also understand the subtraction part. So you take this as 1, this is 2. Now I take one more thing here about the difference. Same vector I will take. See carefully. Vector AB we have, right? Then we have here vector BC, correct? And this is vector A and this is vector B, and here we had the third side giving the resultant, nothing but the addition A plus B. Now if I just go in reverse direction of this vector, okay, arrow mark that I give here, reverse direction, I mean, so this is C, okay, C. So if I go in the reverse direction, yeah, here, and let's say that this is C dash. Now whatever length is the same length is here, but the directions are opposite. So this will be, see, this is vector B, so it should be what? Minus vector B. Now again, if you see carefully, the terminal point of the vector AB coincides with initial point of vector BC. Therefore, the resultant is given by the third side of the triangle. The resultant, that is vector A plus minus of vector B. So this will give you the difference, which is same as what? Vector A plus into minus B. Okay, fine. Now let us move on to, and this we call triangle law. That's what I said, no? Triangle law. Now there is one more law for vector addition, that is parallelogram law of vector addition. Now see carefully here what this law says. Let us suppose that I have got two adjacent sides, that is here vector AB, and I have got here vector AD. This is vector A and this small vector B. I want to know the addition. Now since we know triangle law, I can just draw a vector parallel to this here. Okay, parallel to this for a while. Let us draw a perfect diagram. Yeah, parallel to this. Now since directions are same and length is same, again this will be vector B and let the point to be C. Now I'm just going to join D and C. Okay. Now see carefully. Vector AB and vector BC. See this part. Is it not again? The terminal point of the first vector and initial point of the second vector coincide. Therefore, the resultant is given by the third side of the triangle. And this third side of the triangle, yeah, and this third side of the triangle is what? Diagonal of the parallelogram. And this will give vector A plus B. Now, if we think with respect to what was given at the beginning, we were given vector AB and vector AD. So, if we just restrict to this and analyze, see carefully, if we get two adjacent side, where, I repeat, if we get two adjacent side of the parallelogram, then the resultant is given by the common point between the two vectors. The resultant is given by the common point between the two vectors. Okay. Now, let us also try to understand what about this diagonal BD. Before that, again, this is opposite. As you know, in parallelogram, opposite sides are equal. And so, vector AB and vector CD both should be same. So, I'll just take CD, no? I'll take DC only, so this will be vector A. Okay. If I write in place of DC, if I write CD, it will be minus vector A. Now, I want to know what could be the diagonal BD. Okay. Let's first draw the diagonal here. So, I want before that, no, let us write it. What we got? Vector AB plus vector BC is equal to vector AC. Okay, now we got the resultant. Now I want to know what could be this vector BD. So let us have this BD, this vector I want to know. So see carefully, to apply this logic, we should have addition, initial point of the, I repeat, terminal point of the first vector and initial point of the second vector should coincide. Now here if you see, for both the starting point only, initial point only, correct? No. So to apply this logic, means triangle law, if I reverse the direction for this direction, and I do one thing to avoid confusion, let us again reconstruct here. Let us not have everything in one diagram. Now what is my things will be focused? See here, I have this vector A, I have this vector to be B, okay, and here is already B, fine. Now I want to know which diagonal, this diagonal, fine. Now for this diagonal, I want to know from B to D. So what I am saying is, to apply triangle law, for first vector terminal point and second vector initial point should coincide. But here both for this vector initial point is same. So what I will do, I will reverse the direction of this vector. If I reverse the direction of this vector, the vector plus B should become what? Minus B, because the direction is opposite. Now if you see carefully, now we have a triangle DAB. So here if you see, terminal point of this vector and initial point of this vector both coincide, then the resultant should be given by the third side of the triangle, nothing but the other diagonal of the parallelogram, and this will be vector A plus of minus B, which is same as vector A plus into minus B. So it means, with respect to parallelogram, if I talk about, one diagonal will be addition of both the vectors and other diagonal will be difference of both the vectors. Who knows, for 1 mark it can be asked. They may say, no, they have given two adjacent side of the parallelogram, find the diagonal. So one time is what? A plus B, other will be what? A minus B. Okay, fine. So having understood this, only one comment I would like to say, coming to this addition part of the parallelogram, this one, see here also we got A plus B, and here also we got A plus B ultimately. Yeah, A plus B ultimately, so they are equivalent. Okay, so now let I also quote some of the properties here of vectors, which is obvious properties. This will be helpful for our who knows 1 marker question. What are the properties? The basic properties like commutative, associative. So first property, yeah, vector A plus B is same as vector B plus A. So order is not important. Next, this is commutative property. Let's mention here commutative. Second property, this is first property here. Second property is associative. What associative property says? Vector A plus B, vector C. If I got more than two vectors, either I add A plus B, then add with C, or vector A then plus add with what? B plus C. Both are what? Same. Next, additive identity. Additive identity, same like matrices. Additive identity, for every matrix A there was a zero matrix. Similarly, for every vector A here we have a zero vector, that A plus 0 will be vector A itself, or vector 0 plus vector A will be vector A itself. Next is additive inverse. Here also for any vector A we have a negative vector which is same as negative vector plus A will give you what? 0 vector. I hope these points are clear. Kindly make a note of this. Dear students, let us move on to the next concept, that is multiplication. Of a vector by a scalar. See, try to understand this first. I want to have multiplication of what? A vector. So there is a vector here, and this vector is multiplied by a number, this lambda scalar. So you want to understand this, and let's try to understand this geometrically, and lambda is any real number. Okay, so let us understand geometrically what this stands for, means what is actually happening. Let us suppose that we have got a vector A. Okay, so I'll take this as midpoint. This is our vector A. Now when I multiply vector A by any scalar, let us say a scalar more than 1, let us see what happens. When I multiply a scalar more than 1, let us suppose that I am multiplying by 2 times of 2, I am multiplying a vector A by 2. Then see carefully, the vector 2A will be double of the vector A in the same direction. So you can regard this as a midpoint for this entire vector. So this is vector A, this is also vector A. Vector A means, I mean to say this length is 1, this length is 1, 1 plus 1 is 2 times of vector A. Okay, I mean to say scalar about. With respect to scalar I am saying. So whenever the scalar is more than 1, the length of the vector will increase by what? Lambda times. Here it is 2 times of the given vector. Let us suppose that the scalar is between 0 to 1. Then what happens? Again, this is regarded as the initial point. So this is the midpoint I have taken. So let us suppose that till here nothing but I have taken half of vector A. So whenever the scalar is means any number, scalar is any number between 0 to 1, then the length of the vector will decrease compared to the given vector, but the direction will remain same. So whenever the scalar is positive, the direction of the obtained vector after multiplying the scalar, that is 2 in this case and in this case half, will be in the same direction. But if I take negative scalar, then see carefully, for this vector A, when I multiply minus, so it will be minus vector A in the opposite direction of vector A. So whenever the scalar is negative, then we get a vector in the opposite direction, and this is in fact negative vector of vector A. Why? So the direction is opposite and length is same, therefore it is negative of the given vector A then. So from here one thing is very clear, whenever the scalar is positive, the direction will remain same as the given vector, and if the scalar is more than 1, then the length will be more compared to the given vector. If the scalar is between 0 to 1, it will be reducing, the length will be lesser than the given vector. If the scalar is negative, it will be in opposite direction. What if lambda is equal to 0? If lambda is equal to 0, then it's just a point now, a 0 vector it will be. So very important here that whenever lambda is multiplied to a vector A, and if you are saying that we are getting 0 vector, the meaning of that is lambda is what? 0. So if at all I should have this all vector, I can say collinear vector, because they are parallel, you can see. And here itself we can have one more way of understanding or mathematically to know, mathematically we can give one relationship for collinear vector, that if I take this as B, vector B, so two vectors B and A are said to be collinear if vector B is a scalar multiple of vector A. In fact, lambda should be non-zero real number, or I can write lambda is any real number other than 0. This will be the condition for collinear vectors. We have already understood what are collinear vectors. Two or more vectors are said to be collinear if they are parallel to the given line. So all are parallel here. So from here I can just say if at all vector B and A are collinear, vector B is scalar multiple of vector A. Okay, I hope this point is clear, and that scalar should be non-zero to be specific. Now having understood this, see carefully, depending on again this one. So what could be the magnitude of this scalar multiple? See, when I talk about magnitude, this magnitude is applied to lambda, then for vector A. So what we can understand from here is, when a scalar is multiplied, I repeat, when a scalar multiplication is performed, then what we can see is whatever the original length is there of the given vector, after multiplication it will become lambda times the length. Okay, and if lambda is 0, surely you will get a 0 vector, length will be 0. Okay, next for unit, and here is a negative vector. For a negative vector, if we just try to analyze from this point of, okay, again I take here lambda into vector A. As soon as a negative vector, lambda value is -1. And as soon as I talk about unit vector, then vector A divided by magnitude of A, nothing but my scalar will be 1 divided by modulus of vector A, and this is a unit vector. Symbol is A cap. So formula to find unit vector will be whatever vector is given here, divide by its magnitude. Let us try to understand the geometry of this. See, let us suppose I have got a vector A like this. This is my vector A, and it's in the direction of AB. Length is AB. When I want to talk about unit vector, the unit vector will be a vector on this only, nothing but collinear to itself. But it will be that vector whose magnitude is what? 1. This will be A cap. So in the vector AB, A cap is a vector in the direction of A only, but the length is what? 1. So A cap is not something different vector. It is the same vector only. Now this vector A can be of AB length of larger than the given vector, or it can be like this also. See, this is your AB. Okay, or still small. I may take. I hope it is visible in camera. So I'll take this much, this small. This might be AB, but our A cap may be of this length. So again, what? It is in the same direction. So blue color is our A cap. Blue color is A cap, and the black color is A. B is only vector A. I hope this point is clear. Ultimately, it will be collinear, nothing but it will be the direction of vector A only. It's not some separate vector. Okay, I hope these things are clear. This will be the basic things. Yeah, this will be the basic things for our next concept. Kindly make a note. Fine. Dear students, having understood some of the geometrical interpretation, now let us move on with respect to component of vectors. But before that, no, when we're discussing the scalar multiple, one thing you should understand that whenever you have got any scalar, and if you're multiplying to vector A, I said it is 0 provided the scalar is 0. Yes. Similarly, if I've got any scalar, I repeat here, any vector multiplied by a scalar, that is 0, will get always 0 vector. Whereas if I've got any scalar multiplied to a 0 vector, the output will be what? 0 only, vector only. Okay, 0 vector only. Now let us try to understand. Recording, no? Yeah, let us try to understand the components of vectors. Components of vectors. Listen carefully. Ready? Let us consider the coordinate axis. It's looking perpendicular. Fine. Which are mutually perpendicular. We have got x-axis here, y-axis, and followed by z-axis. They are mutually perpendicular and intersecting at origin, capital O. We are dealing with 3 dimensions throughout the vector chapter, and the next chapter 3-dimensional geometry. Now see here, I will take point A here. Okay, I'll take point A here. Better. This is point B, and this is point C. Each of this length is 1. This length is 1. This length is again 1. And this length is also 1. Don't forget, any point lying on x-axis is of the form x comma 0 comma 0. So the coordinate of point A will be 1 comma 0 comma 0 because lying on x-axis. On y-axis, we know the coordinate is 0 comma y comma 0. Don't forget, in 3 dimension, when I talk about the point, first is always x coordinate, then y, and then z coordinate. So here, since the length is 1, so this point B coordinate will be 0 comma 1 comma 0, and lastly for point C, the coordinate will be 0 comma 0 comma 1, because any point lying on z axis is of the form 0 comma 0 comma z. So what I mean to say is, the length of the vector, I give the arrow mark here, this 3 vector, that is vector OA, length if I talk about is same as length is 1. Okay, then length of OB is also 1, and the length of OC is also 1. Nothing but all are what? Unit vector. And these are along x-axis, y-axis, and z-axis. And this vector along the coordinate axis is denoted as vector OA is I cap in this diagram. Okay, in this diagram, when I write another particular problem, no, where vector OA, don't think as I cap. In this diagram, this entire vector OA is denoted as I cap. So this is I cap here. Similarly, vector OB, that is here, denoted as J cap along which axis? Y axis. And vector OC is denoted by K cap. So what are I cap, J cap, K cap? These are, okay, the vectors. Okay, this one, that is I cap, J cap, and K cap, are unit vectors along positive direction of x, y, and z axis respectively. I have used the word respectively. What's the meaning? Along positive direction of x-axis is I cap, along y-axis is j cap, and along z-axis is k cap. And since from the diagram we know that x-axis, that is here, this is actually x-axis, y-axis and z-axis are perpendicular, mutually perpendicular, and I cap is lying on x-axis, j cap is along y-axis, and k cap is along the z-axis. This also implies that I cap, j cap, and k cap are mutually perpendicular. Mutually, this symbol for perpendicular to each other. So whenever we have a question, what's the angle between I cap, j cap, k cap? The angle is what? 90 degree, because they are lying on x-axis, y-axis, z-axis, positive direction. So what about negative direction? Minus I cap, minus j cap, minus k cap. Here we are only bothered about positive side. We'll talk about even negative, it's understood. Okay. For example, I can extend here, and I can extend here, and extend below here. Okay. Now, having understood this, let us try to now discuss with respect to a general point x comma y comma z. See carefully. Having this logic, again if we construct, and here we should understand now, when we are talking about scalar multiplication just now which we completed, here the scalar is 1 for j cap, where for I cap also scalar is 1, k cap is also scalar 1 there. So, having understood vector components with respect to the unit vectors I cap, j cap, k cap along the coordinate axis, let us move on for a general point. I mean to say position vector. See, already we have discussed position vector. What is position vector? Any vector whose initial point is origin. So let us have a coordinate axis. Is it looking? Oh, the line is bending. Yeah, this is much better. So this is y-axis, z-axis. We know that x-axis should be mutually perpendicular like this, but since board is 2-dimensional, we cannot draw x-axis like this. So we are drawing a slant. Okay, x-axis here, and yeah, fine. Now coming to the point, is this looking straight? Yeah, fine. So now moving on to the point. Let's consider a point here. I will erase this part. I hope you have made a note of this. Now see this carefully. When we are talking about any point P, a general point P of x comma y comma z, I want to understand that point P of x comma y comma z is actually here. It's not on the board. But since if I write P here, no, x comma y comma z, we can't visualize, we can't see that. Until as we won't see, we are not able to visualize. There is a reason we are forced to write on the board, which is 2-dimension. Okay. So now, let us say that from this, I'm going to drop a perpendicular on this plane. And again, I'll just draw a line here. Fine. And drop a perpendicular on x-axis for 4. I'm dropping a perpendicular on, yeah, x-axis. Let us join this. Okay. Now, let us also extend z-axis a bit more. Yeah. Now see carefully. Let us join this. And let us drop on y-axis. Let us use this blue color, as it is going to overlap the point. Yes. Okay, fine. And let us join this. This is the origin. Okay, so we can see a cube. As I'm saying cube now, I would like to say parallelepiped. Okay, so anyway, it's a 3-dimension figure we have got. See carefully along x-axis. So O, let's say O here, OA, and our thing is we want to find this vector R. Vector R is the question mark. Vector R is vector OP. So our target is what is vector R? That is vector OP, and the point P is having the coordinate x comma y comma z. Okay. So now, as we know, along x-axis it is I cap, along y-axis j cap, along z-axis k cap are the unit vectors. But let us suppose I say 2 I cap. Understand this? 2 I cap means from the origin along x-axis the length is 2. So somewhere here, then the point will be, let us suppose some a dash, the point will be 2 comma 0 comma 0. So from here till here it will be what? 2 I cap. So as we discussed already that when a scalar is multiplied, if it's a positive and more than 1, the length will increase, and if the scalar is between 0 to 1, the length will decrease, and if the scalar is negative, it will be in opposite direction, nothing but a negative vector. So here also along x-axis, along x-axis, the unit vector is I cap and the scalar is x, as we can see the x coordinate. Along y-axis from here to here, it is what? J cap, and the scalar is y. Along z-axis, it is k cap and the scalar is z. I hope this point is clear. Now see carefully. Let us name this. Let us suppose A is mentioned. So B here, C here, D here, then E here, and F. So we can see very clearly that since it's a square, you can see this square, or okay, you can say also a rectangle, need not be a square, but you can see this is here OA and EF are parallel and it is of same length. So I can also say that this length, this vector is also, this is a vector here, okay, OA and OF both are same. So I can say this is YJ cap. So see carefully, from origin we have a vector, OE is XI cap and EF is YJ cap. So you can see that terminal here, I can apply triangle law. What's happening here? This OE and EF sum is given by this diagonal OF, and it is sum of these two by triangle law. What it says, if two side is arranged such a way that terminal point of the first vector coincide with initial point of the second vector, then the resultant is given by the third side of the triangle. So you can see OEF in this triangle, this will be the resultant. So that will be XI cap plus YJ cap. Okay. Next, don't forget our target is to find what is vector R. Again, if you see PF is parallel to OC, and let us say the direction is always it's on positive part of z-axis. So again these two are same, so equal vector, they are in same direction. So again this length and this length is same, so it is ZK cap. So see carefully, now we have one more triangle OFP, this triangle, and again for this here if you observe, terminal point of the first vector and initial point of second vector both coincides, then the resultant is given with third side, and the third side answer, that is this vector R, will be addition of these two, that is XI cap plus YJ cap plus ZK cap, because here ZK cap is there. So we came to know that if the point P is x comma y comma z, then the position vector OP, nothing but vector R, is given by this, nothing but XI cap plus YJ cap plus ZK cap. So whenever you have been given a point, you can always write a vector. Hope so it's recording. Yeah, you can write in terms of vector. So XI cap plus YJ cap plus ZK cap. X component will have X coordinate will have I cap, Y coordinate will have J cap, and Z coordinate will have K cap. What about the length? What about the length OP? This magnitude which we are talking about, This also we can get. See carefully. Either I can think of applying the distance from the directly for OP, or let us go step by step itself. I want to find OP. Okay. Now to get OP again. Okay. See carefully here. We are going to apply Pythagoras theorem twice. After applying the Pythagoras twice, we are going to get the magnitude. So this, as I said, OQ means OP can be obtained the magnitude by applying Pythagoras theorem twice on this triangle. That is, see this carefully. So to get this, here we have got this triangle OEF. So if you are going to apply Pythagoras theorem, there we are going to get from here OF to be root of OE square plus EF square, which will OF, what's the length of OF? We don't want vector. OE and EF, I mean to say OE and EF square. OE is X and OF is Y square. Okay. Then again in this triangle, which one? FO, I mean say POF, right angle triangle. Again applying Pythagoras theorem. So let's suppose this is what? In right angle triangle. Which one is that? OEF. Similarly again in right angle triangle, which is that? OFP. Again here we can go sorry, OP is equal to square root of OF square plus FP square. What is OF? OF is here root of X square plus Y square. Don't forget we have square here. Plus FP. FP Z. Again, we are not getting K cap, we want only length. So root S will get cancelled. So what will you get? The length OP, whether OP with magnitude or only OP, both are same. We already discussed the notation. So square root of root S square got cancelled, so got X square plus Y square plus Z square. So this will be the magnitude of the given vector OP. So in short, if you just see the vector OP, which is xi cap plus yj cap plus zk cap, magnitude will be I component square plus j component square plus k component square. That's it. For example, let us suppose that we have been given one vector A is equal to, one example we are taking, if vector A is equal to I cap minus j cap plus 7k cap, then the magnitude of A, the length of A will be square root of I multiple is 1, so 1 square, plus j multiple is minus 1, so minus 1 square, plus k multiple is 7, so 7 square. 1 square is 1, minus 1 whole square is 1, 7 square is 49, so root of 51. Therefore, the length of the vector A is root 51. And here also we can understand one more thing. When we are talking about the length of a vector, it's also actually distance between the origin and the point, the direction ratio. Don't forget this. As soon as I got this vector, the x, y, z are known as direction ratio or direction number or rectangular component or scalar component. Already we have discussed this point. Okay, fine. So let's move on to the next part. Kindly make a note. So now, dear students, let us go for algebra of vectors. Nothing but as we have known the component form of a vector. Now, how are you going to add, subtract, multiply, scalar multiplication? I mean to say, and then under what condition we say it's collinear, then equal vectors. Let us try to have a discussion. See carefully. Moving on to, better I'll give the heading as algebra of vectors now. Algebra of vectors. So see, when I say algebra of vectors, I mean to say addition, subtraction. So for that, minimum 2 vectors are required. So let us suppose the vectors are, if vector A is equal to A1 I cap plus A2 J cap plus A3 K cap, and vector B is given as B1 I cap plus B2 J cap plus B3 K cap, then first point in this, how are we going to find sum? Other name for sum will be resultant, and the other name for this will be addition. So whether they say addition, resultant or sum, all means what? We have to add them. How are we going to add two vectors? Vector A plus vector B. We are going to add I component with I, J component with J, and lastly K component with K. So I component of the vector A and then vector B. So here it is A1, sign is plus, so plus, and here for I component of vector B is B1. For vector A, J component is A2, then similarly here B2, then here A3 plus B3. That's it. Next point, how are we going to go for difference of two vectors? Same procedure, vector A minus vector B, again I with I, J with J component, and lastly K with K component. See, vector A have got the same sign preserved, whatever the sign is there. So here I write A1 I component, then J component, and then K component. Then we have minus, okay, give minus for all. Then vector B component, what's that? B1, B2, and then B3. That's it. Then let us move on to scalar multiplication. Scalar multiplication of the vector. See carefully here. Coming to scalar multiplication, let us suppose lambda is any scalar and I want to multiply to vector A. So lambda times of vector A is here, which is A I cap plus A1 I cap, you're going to say. Then A2 J cap here, sorry. So A2 J cap plus A3 K cap. Now this scalar, that is lambda, should be multiplied to each and every components. That is here, here, and here, A1, A2, A3. So we are going to have lambda A1 I cap plus lambda A2 J cap plus lambda A3 K cap. Here I would like you to make a remarkable note we can have here. See, as soon as I say lambda is equal to 0, we said no, if a scalar is 0 and if you multiply to any vector, we will get a 0 vector. You can understand from here. As soon lambda is equal to 0 here, so 0 into vector A, even though vector A I gave some components here, need not be 0 components. But now, when lambda is equal to 0, about 0 into A1 is 0. 0 into, so lambda is 0, no? So 0 into A2 is 0. Then 0 into A3 is also 0. So whenever we multiply by scalar that is 0, the vector will become a 0 vector. Don't forget this is 0 vector. Okay. Next comes equality of two vectors. When do we say two vectors are equal? See, coming to different forms of vectors, we discussed that the direction and magnitude should be same. Now in terms of component, when do we say vector A is equal to vector B? Vector A is equal to vector B if and only if I component with I component, nothing but A1 should be equal to B1, comma, J component with J component A2 is equal to B2, and K component A3 should be equal to B3. I hope this point is clear. Okay. Next, what about collinear vectors? See, coming to collinear vectors, already we discussed in diagram, means geometrical representation of scalar multiplication on a vector, that if two vectors are collinear, vector B should be scalar multiple of vector A, and lambda is obviously a non-zero scalar. Now let us try to achieve one more condition for collinear vector. One condition is this, which we saw from the diagram approach, correct? Now just see, vector we will substitute here, that is B1 I cap plus b2 j cap plus b3 k cap plus is equal to lambda times of vector A. Vector is this here. So it is a1 I cap plus a2 j cap plus a3 k cap. Now we are going to perform scalar multiplication. This lambda should multiply to each and every term. So we are going to have lambda a1 I cap plus again lambda multiplied to this lambda a2 j cap plus lambda into a3 k cap, and in the left hand side we can retain b1 I cap plus b2 j cap plus b3 k cap. We have equality here. We have equality here. So recall when do we say two vectors are equal? I component with I, j with j, and k with k component should be equal. So we have to equate those components. So here our I component is b1 and here it is lambda a1. So I have to equate. So b1 is equal to lambda times of a1 comma b2 is the j component. I should equate this one with the j component of the other side vector, that is lambda a2. So b2 is equal to lambda a2, and lastly b3 should be equal to lambda times of a3. Solve for lambda, cross multiply. b1 divided by a1 is equal to lambda, then b2 is equal to lambda, that is cross multiply this a2, and b3 is divided by a3 is equal to lambda. Since all are equal to lambda, we can just say that b1 by a1 is equal to lambda. Lambda is what? b2 by a2 is equal to lambda, again what? b3 by a3. This will be the condition for collinear, nothing but direction ratios are proportional. This implies direction ratios of two vectors are proportional, only then they are collinear. Now see, when I say direction ratio proportional, it also means that even if I want, I can take reciprocal. So I can have this one to be a1 by b1 is equal to a2 by b2 is equal to a3 by b3. No problem, both are same. This will be equal to lambda, this will be equal to 1 by lambda. Okay, so we have discussed all the basic concept. Now let's move on to two important derivation, that is section formula and vector joining 2 points. Okay, kindly make a note. Dear students, before stating deriving the vector joining 2 points, let us go for some properties. Let us discuss some properties on scalar multiplication. Properties on scalar multiplication. See, let us suppose that we have got two vectors a and b, and we have two scalars, that is k and l are some real number, the scalars. Now let us suppose that we have got two vectors a plus b, and this is multiplied by a scalar k. So we can either add the two vectors then multiply the scalar, or we can multiply the scalar to both the vectors and then k into a and k into b. Then after multiplying the scalar, we can add them. And don't forget, whenever you multiply any scalar by a vector, the output is again a vector. We just saw in the diagram approach that the scalar is just going to either increase the magnitude or decrease the magnitude, or it can go in opposite direction, or ultimately it can be a zero vector if scalar is zero. Ultimately the output is a vector. Next, let us suppose that I have got two scalars and then I want to add them. Either I can add both the scalars and then multiply with the vector a, or I can just perform individual multiplication, that is k into vector a plus lambda into vector a. This also fine. Okay, so having understood this, let us move on to vector joining 2 points derivation. So coming to vector joining 2 points. So how are we going to, if I have got 2 points, I want to find a vector joining those 2 points, how we are going to get? On that we are going to have a small derivation, and if this comes, it's a 3 marker derivation. Let's consider the coordinate axis. Here it is x, then y, and then z. Is we call right-handed system. So see carefully, I have got a point P1 and I've got one more point P2. The coordinate of the point P1 is x1, y1, z1, and the coordinate of the point P2 is x2, y2, z2. I hope till here it's clear. Now see, if I just talk with respect to a line joining these 2 points, how many line can be drawn passing through P1 and P2? It's only one. Correct? No? So only one line. So we are getting the uniqueness of the line. As soon as we have got a line, for that if I give an arrow mark, it becomes a vector. This is a vector directed from P1 to P2. Directed from P1 to P2. What's the meaning? I am moving from P1 to P2. Initial point is P1, terminal point is P2. I want to find this vector. And these 2 points P1 and P2 can be joined with respect to the origin O. So let us join them here, and again OP2, and again I'm giving an arrow mark. As soon as I have given the arrow mark, we can see a triangle here, which is at OP1 P2. So in this triangle we can apply triangle law. By triangle law, you can see very clearly that in this part, terminal point of the first vector and initial point of the second vector coincide. Therefore, the resultant is given by the third side of the triangle, that is OP2. So we have OP1 plus P1 P2 vector is equal to OP2 vector. Don't forget, our target is to find what is P1 P2 vector. P1 P2 is here, so I can transpose this. So I can have vector P1 P2 is equal to OP2 vector minus OP1 vector. So this is the vector joining the 2 points. Now here derivation not complete, I have to still complete. But before I go ahead, see this. In P1 P2, which is the first letter P1, second P2. So it is the difference of second letter minus first letter with respect to position vector. Position vector means initial point should be origin. Yeah, initial point is origin, that is O. Now it is complete. Just now we have learned in component form of vector that as soon as I have got P1, from here I can say vector OP1 is x1 I cap plus y1 j cap plus z1 k cap. Similarly, point P2 coordinates are this. So I can say vector OP2 is x2 I cap plus y2 j cap plus z2 k cap. Let us not forget this. Now let us substitute all this here. So I am going to substitute here. Vector OP2 is here. That is x2 I cap plus y2 j cap plus z2 k cap minus vector OP1 is here. That will be x1 I cap plus y1 j cap plus z1 k cap. Here we have got difference, so bracket C minus is multiplied to the entire vector OP1. So OP1 is this entire, so bracket is mandatory. If bracket is not given, negative is only multiplied to the first component for the remaining. Now let us simplify. First vector, okay, we'll do one thing. First we'll multiply the negative here. So I will write as it is this. Now see carefully. This is 2. Minus into plus is minus x1 I cap, minus plus is minus y1 j cap, minus plus is minus z1 k cap. Now see here carefully. How to subtract two vectors we have learned. Subtract I with I, j with j, and k with k. Let's have some more space here. So see carefully. I am going to have vector P1, P2 is equal to I cap. If I have written this How to subtract? I with I component, x2 minus x1 plus j cap. What is j cap multiple here? Y2 and here minus y1. So y2 minus y1. Then plus k cap. K cap multiple is z2 here minus z1. So z2 minus z1. This will be a vector joining the 2 points. I am not asking to memorize this. I just want you to remember this. That as soon as you have got 2 points, it's always the terminal point minus initial point, okay, of this vector. Vector joining 2 points. Now from here, where what is x2 minus x1, y2 minus y1 and z2 minus z1 are called scalar components or rectangular components or direction ratio or direction number, okay, ratio. And what about, see this, what about x2 minus x1 I cap, nothing but this entire part, comma, y2 minus y1 j cap and z2 minus z1 k cap. What about this? See, a scalar is multiplied by vector. So output is what? Vector component. Vector, no? Output is what? Vector. So we call this as vector component, are called what? Vector components. Now, having this, what about the magnitude of this? Let's complete here. What about the magnitude of this? See, the magnitude of this, magnitude of vector p1, p2. So magnitude of that is given by, either I can use distance formula, or already we know that if I know the vector, then the magnitude is given by square root of sum of the square of scalar components. So what are scalar components here? x2 minus x1, or you can use distance formula, x2 minus x1 the whole square plus y2 minus y1 the whole square, then plus z2 minus z1 the whole square. That's it. So this will be the magnitude. Okay. So now having all this understood, let us move on with the last derivation, section formula. Then we'll take up the problems. Okay. And here to add one more property, we can also have no k into L no into vector A. So either we can multiply L with vector A, then multiply with k, or L into k into vector A, or k into L into vector A. Are some basic things. Okay, nothing much, something like we are not knowing. I am writing this one all, who knows, for 1 mark it may be useful. Which of the following is false? Like that. Kindly make it out. Okay. Dear students, let's move on to the next derivation. That will be the last concept for this exercise, and then we can take the problems on this. It is regarding section formula. Let us recall this. First, in Cartesian form, what was actually and why was the need of section formula? See, if you have got a point, okay, line joining 2 points P and Q, there is a point R which divides them in some ratio, let's say m is to n. I want to find this point which divides the line joining PQ in the ratio m is to n. The same thing we are going to go for vector concept, that we have got a point P here and Q, and there's one point R which divides them in the ratio m is to n. And now since it's a vector concept, so from P to Q we are moving. Now see, this point P, R and Q can be joined with respect to origin. So origin is here. So now we are going to join them with respect to origin. So OP, then OR, then OQ. So all this recording no? This is vector A, this is vector R, and this is vector B. So we have taken the position vector of the point P, R, Q as vector A, vector R and vector B. Don't forget, since we want to find the point R, we mean to say that we have to find the vector R here. Now see from the diagram very clearly, is it not the ratio M is to nothing but M by N. M is given by PR and N is RQ. On cross multiplying RQ, okay. On cross multiplying, and this is a 3-marker question and it has been asked in the model question paper as well. I think model question paper number 3. I'll just mention the question number after I complete the derivation. Now see carefully. So if I cross multiply this, we are going to have M into RQ is equal to N into PR. Be careful, when I was writing this, I didn't put arrow mark here because right hand side, left hand side both are not vector quantity. This is scalar quantity here. Now I can write vector RQ and here N and vector for a while cross multiply. Yeah, PR here it is. Sorry. So vector PR. Now from here, RQ, see, RQ is a vector joining 2 points, that is R and Q. And just now we have learned vector joining 2-point concept. Let us write that. So vector RQ, in this R is the first point and Q is the second point. So it is second point minus the first point. That's what I asked you to remember. Is equal to N. In PR, P is the first letter and I is the second letter. So it is OR minus OP. From the diagram, what is vector OQ? Vector OQ is vector B minus vector OR. OR is vector R here, is equal to N times of vector OR. What is vector OR? Vector R here minus vector OP. Vector OP is vector A here. Now from here, just we have to simplify for vector R. So simplify this, M into vector B minus M into vector R. Again multiply N into vector R minus N into vector A. Now simplify for or solve for vector R. So here I can just transpose this and here I can transpose here. So I get M into vector B plus N into vector A is equal to M into vector R plus N into vector R. Now since I have to solve for vectors, common is here vector R. So remaining will be M plus N. And here M into vector B plus N into vector A. Now since I want vector R, cross multiplication can be done or divide by M plus N. So we are going to have vector R is equal to, I am writing this vector R in the left hand side, is equal to M into vector B plus N into vector A divided by M plus N. So this is the position vector R. Okay, so I can also say this is vector OR, which is equal to vector R is equal to M into vector B plus N into vector A divided by M plus N. And here be careful, see the way we have got expression. M is multiplied to vector B, that's what you can see here, and N is multiplied to vector A, nothing but like this cross, divided by sum of the ratio. Now let us suppose that we have completed internally. For all the question is on internally, yes, our job is done. And for 3 marker, it is on internally. Let us suppose we want midpoint, nothing but this point R is dividing the line joining or the vector PQ in the same ratio, nothing but M is to N are same, M is equal to N. Then comes midpoint formula. The ratios are same. So if I put N is equal to M in equation number 1, let us suppose that this is equation number 1. So vector R is equal to vector OR is equal to, put here in place of N it is M. So m into vector b plus, again in place of n it is m into vector a divided by m plus n, in place of n again m, so m plus m. So you can see m is common numerator. That's what I gave the property of scalar multiplication on vector. So you get vector b plus vector a divided by what? M plus m, 2m. So you can see very clearly m by m will get cancelled. So, and we know that under vector addition commutative is 2, so I can write b plus a as a plus b divided by 2. So this will give us midpoint. And same like our Cartesian form, where the midpoint formula is x1 plus x2 by 2, y1 plus y2 by 2, and z1 plus z2 by 2. Addition of the coordinate divided by 2. Next comes external. See, for external there is no need of any derivation. Just what we are going to do for external is nothing but this point R is dividing from the out. See, the diagram will be like this. Here we have Q, here we have P, and here we have R. This R is dividing PQ from out, means it is outside QP. So this ratio is M and this ratio is N. Okay. Or if I go with this, then this ratio, anyway, no problem. I can also say this is M and this is N, then also fine. So we are going to have this, we can replace, without, we are not going to go for any derivation for this, replace n by minus n in equation number 1. We are going to replace n by minus n in equation number 1, that is here. So vector r is equal to m into vector b, in place of n it is minus n, into vector a divided by m minus n. Obviously in the examination description of the diagram should be given. It's very simple. Consider description of the diagram, means what you can see in the diagram, just you have to write. So we just going to consider 2 point P and Q, which has been divided by point R, and whose position vectors are OP, OR and OQ, given by vector A, vector R, and vector B, and R divides PQ in the ratio m is to n. That's it. Okay, fine. Then I just write which year it has been asked. Just make a note till then. Yes, dear students, this is a question for this derivation. Question says for 3 marks from model question paper number 3 from KSEAB, show that the position vector of the point P, which divides the line joining the points A and B, having the position vector A and B internally in the ratio m is to n, is given by this. That's what we have got here. But in place of taking P and Q, they have said A and B. So just here we have to change the things. If at all we have to go with that, because they have given A and B as a point. So either we can assume A to be P and B to be Q, or we can just change this as A and this as B. Okay, so then A R it is. So this will be A, then R, and this will be R, so that no, there won't be any confusion. I'm just changing. Explanation, no change. Again, I cross multiply. Here it is B, and here it is AR, right? Again, here it is R with B here, and this will be AR. So what is vector RB? OB minus OR, and vector AR will be OR minus OA, and the remaining no change. Okay, fine. So kindly make it out. Okay, dear students, now time for solving the problems on 1 marker on the concept whichever we have discussed. So model question paper number 1, a 1 marker question from multiple choice question. Question says for the given vector AC is, they have given a triangle. So surely we have to apply triangle law. Recall what was triangle law. It says if 2 vectors are arranged such a way that the terminal point of the first vector coincide with initial point of the second vector. See this carefully. If you see this, here both are initial point. So I cannot think of those two vectors for applying triangle law. If you see these two, yeah, this is initial point and this is the, I mean to say this is the terminal and this is the initial. So I can apply triangle law. So what about this? Both are terminal. So here from triangle law, solution by triangle law, we can say that vector AB plus vector BC is equal to vector AC. What is vector AB? Minus 2A. What is vector BC? Vector 3B is equal to vector AC. Yes, we got the answer. Minus 2A plus 3B. Minus 2A plus 3B. Option W is correct. Okay. Now moving on to next question. Again a one marker question. Multiple choice question. The direction ratios of the vector joining the points P and Q directed from P to Q. Very important. Directed from where to where? P to Q. So it's a vector joining 2-point concept. So coming to the solution of this, point P is 2, 3, 0. So vector OP will be 2I cap plus 3J cap plus 0K cap. And vector OQ will be here minus I cap, then minus 2J cap plus 4K cap. Since I want vector joining PQ, so vector PQ will be OQ minus OP. See carefully, in the vector PQ, first letter is P, second is Q. We are not following the order of English alphabet. In this order, first is P, other is Q, the second letter Q. So second letter minus first letter. Okay. So vector OQ is here. So minus I cap minus 2J cap plus 4K cap minus vector OP is here. That is 2I cap plus 3J cap plus 0K cap, and we can give a bracket. Why? Minus is multiplied to vector OP. Now how are we going to subtract two vectors? I with I, J with J and K with K. So first vector as it is, that will be minus I cap minus 2J cap plus 4K cap. Then minus into plus will be minus, minus to plus will be minus, all will be negative now. So minus 2I cap minus 3J cap minus 0K cap. Now let us simplify. How are we going to add or subtract two vectors? I with I, J with J, K with K. So minus I cap and minus 2J cap will be minus I cap minus 2I cap will be minus 3I cap. Then minus 2J cap and minus 3J cap will be minus 5J cap. Plus 4 and minus 0 will be plus 4, then the K cap. Direction ratios are this, nothing but minus 3, minus 5, 4. Minus 3, minus 5 and 4 is in option A. So option Alu is correct. Okay, nickname Alu. Next, fill in the blanks question for 1 mark. The value of lambda for which these two vectors are collinear. Recall, for a vector to be collinear, direction ratio should be proportional, or one vector should be a scalar multiple of other. There the scalar we use lambda. This lambda is not that lambda which I have taken for scalar multiple. Okay, so it's just a same symbol used. Okay, now see, since collinear, is it not this vector and this vector scalar component should be proportional. So 2 divided by minus 4 should be equal to minus 3 divided by lambda should be equal to 4 divided by minus 8. Now see here, 2 1s are 2 2s are 4 1s are 4 2s are. So minus half minus half. Either you can equate. Okay, first other side, minus half is equal to minus 3 by 6 is equal to minus half. So either you can equate this. Okay, lambda here, sorry, or you can equate this, whichever, both are same. No, so now negative will get cancelled throughout. So I can just cross multiply. Okay, let's say 3 by lambda is equal to half. So cross multiply, 2 3s are 6 is equal to lambda. Value of lambda is 6. Okay, I hope this point is clear. Kindly make a note. Okay, dear students, now let us move on to the next problem from model question paper number 3. Yeah, I know you'll be wondering what about model question paper number 2. Those problems, I mean to say from model question paper number 2 are from third exercise, that is dot product and cross product. After I complete the concept, after complete this problem, I'll take the dot product concept, then I will discuss the problem as usual. Without concept, no problems. Question says, a one marker question. In vector addition, which of the following is not true? So coming to vector addition, recall triangle law is used. So here for vector addition, triangle law is used. So vector AB, then BC, then AC. Correct? If terminal point of the first vector coincide with initial point of the second vector, then the resultant, nothing but the addition, is given by the third side of the triangle. So from here, it's very clear that vector AB plus vector BC should give us vector AC. I repeat, vector AB plus vector BC should give us vector AC. As you can see, all the option right hand side is 0. So if I just transpose, or I can say subtract by vector AC both the side, then we'll get vector AB plus vector BC minus vector AC is equal to 0 vector. They want which of the following is not true. Okay, not true. So see carefully, this part is there in option B, so this is true, but they want not true. Now if you see very carefully, okay, if you see very carefully, option C is not true. It is minus AC vector, but here it is minus CA vector. So not true is option C. Okay, I think it's false. But to have a still more clarity, let's see option E and option D, even though we have got the answer. So see, we have got positive. Okay, we know that minus AC vector and CA vector both are what? Negative of each other, negative vector. And I said just now, to get the negative vector, just you have to change the location of A and C. As soon as I change the location, I got minus. So this is vector CA, and there is no change for the remaining. If I retain as it is, that is obeying with option A. This is also true. Now moving on to the last option. See here, AB, yeah, AB, CA and CA, but here we have what? Minus CB, yeah. BC vector and CB vector are negative of each other. So the directions will be opposite. Here the initial point is B, terminal point is C, but here initial point is C and terminal point is B. So we are going to have vector AB minus vector CB plus CA vector is equal to 0 vector. This is matching with option D. This is also true. Okay, so option Chalu, C is not correct. Now coming to assertion reason type question. Question 12, one marker question says, the assertion is the two vectors, vector A and vector B, are collinear vectors. And the reason for this is, if two vectors are collinear, then vector A should be a scalar multiple of vector B, where lambda is any scalar, and they are given the options. Okay, fine. Coming to the solution of this and coming to the assertion part, the vector which we have got, see vector B carefully. Vector B, let's copy down, minus 6i cap plus 3j cap minus 6k cap. If you see carefully here, 3 is common. Okay, minus 3 is common. So minus into minus is plus, 3 2s are 6. Minus plus is minus j cap. Minus plus 3 2s are 6. So then we have minus 3 times of this entire thing is same as vector A. Can you see? 2i cap minus j cap plus 2k cap, nothing but vector A. So vector B is scalar multiple of vector A. The scalar is minus 3. So, see, some people will have doubt, sir, A should be a scalar multiple of B. See, whether A is scalar multiple of B or B is scalar multiple of A, ultimately they are collinear. For example, this, no, A is scalar multiple of B. I can also write this one for a while, write properly. Where vector A is scalar multiple of B, correct? This can also be written as cross multiply lambda. Then I get 1 by lambda vector A is equal to vector B. So vector B is also a scalar multiple of vector A. So there's nothing like lambda should be only with B or A. It can be anywhere. Okay. So vector B is a scalar multiple of vector A. Hence, what? Collinear. Vector A and B are collinear. So both collinear vectors, fine. So both the statements are true. So option D is correct. I hope this point is clear. Kindly make a note. Dear students, before moving on to dot product, I just want to take one small concept where I want you to have a clarity between direction ratio, direction cosine, and how to find unit vector. See, as soon we talk about any vector A, and here if I just write xi cap plus yj cap plus zk cap, there is no, when I take the magnitude of vector A, we know it is root of x square plus y square plus z square. Until unless the sum of the square is not equal to 1, it's not a unit vector. And since the sum of the square of this component, scalar component, that is x, y and z, is not equal to 1, therefore it's not direction cosine, but it is a direction ratio. So the direction ratio is x, y, z. Okay, this is the direction ratio. First point. Now second point, let us suppose that the scalar component of vector A are direction cosine. So the direction cosine for the vector A. So if now I'll do one thing, I'll take as vector B here. Vector B scalar components are direction cosines, that is cos alpha, cos beta and cos gamma. Now if I take the magnitude of vector B, this will be equal to square root of cos square alpha plus cos square beta plus cos square gamma. And we know that sum of the square of direction cosine is equal to 1. We have already, actually I have already proved at the beginning of the class. So cos square alpha plus cos square beta plus cos square gamma is always equal to what? 1. So root of 1 is what? 1. So what do we understand here? That whenever the scalar components are direction cosine, always the magnitude of that vector will be 1. Nothing but as soon the scalar components are direction cosine, then the given vector will be a unit vector. Okay. So where this cos alpha, we also know that cos alpha is denoted by L, cos beta is denoted by M, and cos gamma is denoted by N. This we call direction cosines. Okay, and if I just put here, it will be L square plus M square plus N square is equal to 1. In place of cos alpha L, in place of cos beta M, cos gamma, as we know it is N, we denote. Okay. Now, having understood this logic, let us suppose, no, this is NCERT one problem is just find the direction cosine for the vector A given as 1i cap plus 2j cap plus 3k cap. This is from the exercise 10.2 and the problem number, let I quote it, it is problem number 12. Question is find the direction cosine. Now see, as soon I just take the magnitude of this, it is I multiple is 1, j multiple is 2, k multiple is 3 under the root. So we have got 1 plus 4 plus 9, that is root of 14, which is not equal to 1, due to which I multiple, that is scalar, 1, j multiple scalar 2 and k multiple scalar 3 are what? Direction ratios. They're not direction cosines. How we came to know? Because the magnitude is not equal to 1. Now, if I find the unit vector, as we came to know here that if at all I want direction cosine, if I take the magnitude and it's equal to 1, always the scalar components are direction cosine. So let us find the unit vector. Vector A cap is given by vector A divided by its magnitude, where the magnitude of A should not be equal to 0. What is vector A? It is here I cap plus 2j cap plus 3k cap whole divided by magnitude of A, nothing but root 14, as we know from here. Now this is your unit vector. Now what I want you to understand and get convinced is whether it is unit vector or direction cosine, your steps are same, your procedure is same. If it is unit vector, you are going to stop it here. But since I have said question is what? Find the direction cosine. Question is what here? Find the direction cosine. Direction cosine. So what we are going to do is split this root 14 should be divided for component of scalar component of I, j and k cap. So 1 by root 14 I cap plus 2 by root 14 j cap plus 3 by root 14 k cap. So therefore the direction cosine are what? This scalar components, which are those 1 by root 14, 2 by root 14 and 3 by root 14. 1 by root 14, 2 by root 14 and lastly 3 by root 14. Okay, I hope these things are clear. So whenever we want to find direction cosine, always find the unit vector and then split them. Separately divide the denominator to each of the numerator. That will give you what? Direction cosine. So this is direction cosine or unit vector. Step is step. Okay, kindly make a note.